Good afternoon, and welcome to the Embedded Executive Podcast. My name is Rich Nass, and I am the Executive Vice President of Open Systems Media. I lead the team at Embedded Computing Design. Here for this week's Embedded Executive Podcast. This week, my guest is Mark Monteith. He is a Corporate Vice President and the General Manager of Micron's Mobile Business Unit. How are you, Mark?
I'm doing great. I'm happy to be here. Thank you.
That's a fairly long title you have there.
I know you more words makes you sound more maybe.
There you go. Sounds good to me. So Micron does memory for pretty much everything, but we want to talk here about the mobile industry and how memory and storage are underpinning some of the latest trends, such as generative AI at the edge. So let's talk about that. So do I have this right? Does your memory really make a difference when you're talking about AI?
Oh, absolutely. I mean, more than it has historically, and I'd be happy to kind of jump into some of the reasons later if you want to understand why.
No, I want you to jump in right now. Tell me.
Okay, right now. Okay. Well, look, we and I imagine most of your listeners have a strong technical background.
Yes.
Embedded compute has always been a story of compute performance, parallelism, and ultimately it's about computer operations per second, tops per second, those kinds of things, right? In that story, for decades, the workloads that we were running were very compute intensive and not so memory intensive. And this new era of AI has really changed the way system designers have to approach the problem. Because to do generative AI, you have massive models, billions of parameters. Can I interrupt
you for a sec?
Of course, yeah.
You said that they used to be very compute intensive, but not memory intensive. But don't those things go hand in hand? Is it possible to have one without the other?
It absolutely is. It absolutely is. Yeah.
So explain that.
Well, we like to call them workloads, but if you look at the characterization of a job you're doing, often it can be incredibly compute intensive, running inside of its local caches, doing mathematical operations to produce a result. The workloads for AI are built on these massive models, billions and billions of parameters that you have to work through as you run the neural net. And so doing that has put new burdens on the memory systems and the memory capacities. And so it really is, von Neumann architecture gets referenced a lot. And in that von Neumann architecture, you have input, compute, and the memory. And the workload, the AI workload, generative AI workload in particular, are massively bound by memory bandwidth and memory capacity. And if I could just say one more thing, you can literally see a direct correspondence between more performance and larger models to overall performance of the model.
Does this discussion pertain to doing all of your calculations locally at the edge as opposed to going to the cloud?
No, it's absolutely true in both cases. If you look at Micron's business in AI, HBM products, one of the reasons we are being so successful with our recent announcement on HBM is we offer the largest capacities and highest bandwidths in the center. So exactly the same thing.
Okay, so now I interrupted you midstream a little while ago. Do you remember what you were talking about at that point?
Well, I was trying to make the case as briefly as I could. A very complicated discussion about the workload of AI having these massive models that reside in memory, and operating through those is putting new strains on systems. And I have lots of figures of merit we could talk to later, but I would just end by saying this: we have graphs and we've done characterization, and more than in any recent workload I'm aware of, as you increase memory capacity, as you increase memory bandwidth, you see a direct improvement in the overall quality and responsiveness of the model.
Okay, what about the buses that these things reside on? Do we need improvements there?
Absolutely, for a couple of reasons. One is the performance that we already talked about, but also because in my unique case, delivering AI to edge devices, we don't get more power. We can't go create a new data center, bring in a new power line, right? We have the power envelope that we have, and so we have to drive all this greater compute efficiency and bandwidth efficiency at the same or lower power. So, the mechanisms for doing that need a generational uplift. And so we're excited about one of those. One of those is that we're going into an era of LP6, which is a new IO with greater bandwidth and lower power. But we'll continue to innovate on this vector.
Okay, so what is Micron doing in that particular space?
Okay. Well, thank you for the opportunity to talk about Micron just a little bit. Micron is a leader in the space and, dedicated to the strategy of delivering industry-leading products. And so industry-leading in the mobile space means we have delivered our very latest process node, which has the lowest power and the best performance, our 1-beta node. And the first product we delivered was a mobile product. And it has industry best performance, 9.6 gigabit per second, industry best power, and we're going to continue to innovate along that vector in future product announcements going forward. Also in storage, at Mobile World Congress, we announced really fast on-device storage, and that's also really important because one of the things that is increasing in importance is the amount of storage you have on your mobile device. Today, most people know a little bit about storage. Maybe they bought their device, 128, 256, even 512 or higher, knowing that they'd be able to store more pictures and videos. What they will come to find out in the era of generative AI is that they also get better performance, having very fast and lots of storage on the device.
Now, in some of the spaces you're referring to, particularly mobile, isn't it imperative to have a second source for memory? If I'm an OEM, I want to make sure that you guys aren't going to have a blip and I got to shut down my production.
Yeah, look, the complication of supply chains around the world is only growing with various risks and various consolidations and the scale required to deliver some of these capabilities. In the memory market in particular, over the last several decades, there's been a real consolidation of players so that the remaining players had the scale to go develop these new nodes and new capabilities. Our customers have their procurement strategies, but our strategy is very clear: is to lift this industry and make it move fast along this key vector, particularly the performance per watt. There's nothing that's going to enable the edge faster than being able to not need this massive new battery or some other plugged in all the time, but to do these workloads on the existing power budget.
Okay. Do you tend to work in lockstep with the OEM, or are you ahead of what that they need, or are you behind what they need?
Yeah. I guess of those three, I'd say lockstep. We have very close relationships with both the ecosystem enablers, the people that make the chipsets that are used in handsets, and then also the end OEM and their system requirements. We work directly with all of them. And look, if for all who watch Mobile World Congress or are plugged into Edge AI, we are as an industry dedicated to doing something profound here, and it needs to be here because while reaching into the data center and doing some of the early workloads in AI like ChatGPT is interesting and even useful for cases, what's really going to impact people is when they can carry it around in the 1.2 billion phones sold every year, or the 6 billion phones that are in use around the world. It's a massive market, and it's where we're all going to really get impacted by AI.
So let me ask that same question a little differently. If you were able to offer higher performance today, would your customers be able to take advantage of it?
Well, okay, that's an excellent question. It really ties back to your earlier one too, right? If as a innovator you get ahead and insular in the technology, that's not good for the ecosystem. And we are deaf about bringing the ecosystem along together. And so, obviously within a certain level of performance, the answer is yes. And were we to do something that required massive changes to SoCs and test capabilities, then we would really be restricting our opportunity. So no, we're definitely committed to bringing the industry along with us.
Cool stuff. This is very interesting, and we could probably talk about this for a lot longer, but I think we should stop right here. Is that okay with you?
Absolutely. Thank you.
Awesome. That was Mark Montier. He is a corporate vice president and the general manager of Micron's mobile business unit. And I am Rich Nass with Open Systems Media. Thank you, Mark. You have a great day.
Thank you.